puzzle in physics today, right?
Absolutely. It's this grand challenge of trying to connect our two best theories of the universe.
You've got general relativity on one side, that's Einstein's picture, right? Gravity, warped space-time, the huge cosmic scale stuff.
Exactly. And then on the other side, you have quantum mechanics. Totally different world. The rules for the super tiny, the particles, and it's, probabilistic, inherently strange.
And the big dream, for ages now, has been to get them to talk to each other. A unified theory. Quantum gravity.
And what's really wild, looking at the material we have, is how a possible key might actually come from two ideas Einstein himself really disliked back in 1935.
Wait, really? Ideas he wasn't happy with?
Not at all, initially. He kind of wrestled with them. One was from his own theory, these theoretical shortcuts through space-time, Einstein-Rosen bridges. Wormholes, basically.
Yeah, wormholes, got it.
And the other...
That came from quantum mechanics, the thing he famously called spooky action at a distance. Entanglement. The Einstein-Podolsky-Rosen Paradox, EPR.
That's the one. Spooky entanglement.
So these two, sort of outlier, spooky ideas from Einstein's time, they might be connected.
That's precisely the core idea we're unpacking today, the ER-BPR conjecture. It suggests these two things, the geometric wormhole, ER, and the quantum entanglement, EPR, are, well, fundamentally the same phenomenon.
Wow. Okay, that's a big leap.
It is. And it potentially changes everything about how we view space-time itself. So that's our mission. Explore this conjecture, see what it means.
All right, let's start with the ER side then. Einstein-Rosen bridges, wormholes. Paint the picture for us, based on GR.
Okay, so imagine space-time isn't just empty space. It's more like a fabric, right? A sheet. And GR says mass and energy warp this sheet. That's gravity. Now, if you have something really dense, like a black hole, the warping gets extreme.
Okay.
So extreme that maybe the fabric folds over on itself, and you could theoretically punch a tunnel through it, a bridge connecting two distant points.
A shortcut. Instead of going the long way across the curved sheet, you pop through the tunnel.
Exactly that. Einstein and Nathan Rosen, they were working on black holes, trying to smooth out these points of infinite density called singularities.
Right, the problematic infinities.
And mathematically, they found this solution that looked like two black holes connected by a bridge. That visualization you mentioned, the direct path versus the long way around, that's perfect.
There was a catch, wasn't there? The source mentions a pretty big limitation with these original wormholes.
Oh, absolutely. A huge catch. These classical Einstein-Rosen bridges, they were non-traversable.
Non-traversable meaning?
Meaning the bridge, the tunnel, would basically pinch off and collapse incredibly fast.
Yeah.
Way too fast for anything, even light, to actually get through from one side to the other.
Ah. So cool math, but not a usable subway system for the cosmos.
Pretty much.
Yeah.
For decades, they were just seen as this interesting mathematical feature, a curiosity, not something physically real you could, travel through.
Okay, so that's one spooky concept down. Theoretical tunnels you can't use. Now, let's jump to the other side. EPR. Quantum entanglement. This feels like a totally different kind of weird.
It really is. It's maybe the most counterintuitive part of quantum mechanics. Basically, you can link two particles, like electrons or photons.
Link them how?
So they share the same quantum state. Their properties become correlated, intertwined, no matter how far apart you pull them.
The source uses the spin example, right? Particles A and B. Before you look, neither has a definite spin.
Correct. They're in a sort of fuzzy state, a superposition. Spin up and spin down at the same time, in a way.
But the spooky part is when you measure one.
That's it. The instant you measure particle A, let's say you find it spin up, instantly, with 100% certainty, the particle B is spin down, assuming they were set up to be opposite.
And this happens even if B is on the moon or in another galaxy, instantly.
Instantly, no delay. And critically, the source is clear on this, and it's important. It's not like finding one glove and knowing the other is its pair.
Right. It's not like the properties were hidden but set all along.
Exactly. Experiments confirm this again and again. The properties genuinely aren't definite until you measure one. The measurement somehow fixes both outcomes simultaneously. That non-local connection is the spooky action at a distance that bothered Einstein so much.
Okay, spooky indeed. But like the wormhole, there's a limit here too. You can't use this to send instant messages, right? No faster than light communication.
Correct. That's a really common misunderstanding.
Yeah.
Yes, the correlation is instant, but you can't control the outcome of your measurement on particle A.
Ah, because it's random.
Totally random. You'll get spin up or spin down maybe 50-50. So you can't force it to be up to send a 1 or down to send a 0, you just get a random result, and B instantly reflects the opposite, but you can't use that to transmit information deliberately.
Okay. So, two very strange ideas from Einstein's time. Non-traversable space-time tunnels and instant quantum connections that can't send signals. Both a bit spooky, both with limitations.
And now, the conjecture that ties them together. ER equals EPR. Put forward mainly by Leonard Susskind and Juan Maldacena.
And the claim is... What exactly?
The claim is bold. It's that the quantum entanglement connection, the EPR link, is the Einstein-Rosen Bridge. They are geometrically the same thing. Two entangled particles are literally connected by a microscopic wormhole.
Whoa, okay. That's connecting the quantum world directly to geometry. Let's unpack those implications the source talks about. First, geography from spookiness.
Yeah, it basically gives the spooky action a physical shape.
Yeah.
Why does particle B instantly know about A? Not magic, the conjecture says, but because there's a geometric connection. They're linked through the back, so to speak, via this wormhole. The entanglement is the wormhole geometry.
So the spookiness gets a physical explanation rooted in space-time structure.
Exactly. And then there's the even more profound idea. Building space-time from quantum bits.
That sounds like it flips everything on its head.
It really does.
Yeah.
It suggests that maybe space-time, the geometry we experience, isn't the fundamental bedrock of reality.
It's not the stage, but part of the play.
Sort of. It suggests space-time is emergent. It arises from something deeper. And that deeper level is governed by quantum entanglement.
So the connections, the entanglement links between all the quantum particles that weaves the fabric of space-time.
That's the core idea. The geometry of our universe, the very meaning of distance and location, might be a macroscopic consequence of this incredibly complex network of quantum entanglement.
And the source mentioned this lines up well with things like the holographic principle, add SCFT.
Yes, precisely. In those frameworks, you have situations where quantum entanglement on a lower dimensional boundary surface mathematically describes gravity and curved spacetime in the higher dimensional volume inside. ER-EPR provides a powerful interpretation. The entanglement is the geometric connection in the bulk, like entangled black holes being connected by a wormhole.
Okay, this is fascinating stuff, but where does ER-EPR stand now? Is it proven? The source seemed careful about this.
Right, and that's crucial. It's not a proven theory yet. It's very much a conjecture, a hypothesis. But it's an incredibly powerful one. Think of it as a new lens, a research program that's guiding a lot of theoretical physics right now.
And the potential payoff is huge, like helping unify physics.
Definitely. It offers dictionary, almost, to translate between the language of geometry, GR, and the language of quantum information, QMIC. That's a massive step towards quantum gravity.
And it might shed light on other mysteries, like the black hole information paradox.
Potentially, yes. If information that falls into a black hole remains entangled with radiation that escapes, maybe the ER-EPR connection means the information isn't truly lost, but accessible through this wormhole link. It opens new possibilities.
But fundamentally, it just gives us a completely different view of space and time.
Yeah, absolutely. It challenges the idea of space as just emptiness. Instead, it's a construct built from these quantum connections. It suggests the universe is interconnected in ways we're only beginning to grasp.
It's amazing how it takes these two ideas that Einstein himself found problematic, these non-usable wormholes and this spooky entanglement, and suggests they're actually two sides of the same deeper coin.
A single, elegant, and potentially revolutionary concept, yeah.
Yeah.
Weaving geometry from quantum threads.
Which brings us to that final kind of mind-bending thought experiment implied by the source material. If space-time really is woven from entanglement, what happens if you could, hypothetically take a region of space and just unentangle everything inside it? Cut all those quantum threads.
Right.
Does the space itself just dissolve? Does the geometry cease to exist in any meaningful way?
That's the kind of question ER-KR forces us to ask. If the connections are the space, what happens when you remove the connections? It's a fascinating, deep question about the ultimate nature of reality.